Okay, our goal in this new unit is to learn to solve triangles that are not right triangles, but instead they're oblique triangles, meaning they don't have a right angle. So we're going to do this once. We won't do it again, but I'm going to show you how we come up with a new formula that tells us about these triangles. I'm going to call this angle A. I'm going to call this angle B. I'm going to call this angle C. So this would be side A. This would be side B. And that would be side C. We okay with that? Now, the truth is, I don't really know anything about triangles that don't have a right angle. So what I'm going to do is I'm going to make a right angle. I'm going to call it H. Do you notice that H is the opposite side for both angle A and B? Which of the three trigonometric functions, sine, cosine, or tangent, have to do with an opposite side? Sine and tangent. I'm going to use sine. Now I'm going to say the sine of angle A is equal to, what is the side opposite angle A? Excellent. A is all the way across here, but I want to talk about in the right triangle. In this right triangle right here, what side is opposite A? H. What is the hypotenuse of that right triangle? B. Now I'm going to do the same thing, but I'm going to use angle B. Sine of angle B is, well, there again I need opposite over hypotenuse. What's the opposite side? H. What's the hypotenuse? A. What do those two expressions have in common? They both have an H. If I wanted to solve for H, I could multiply by B, correct? And I would get sine of A times B is equal to H. Multiply both sides by B, and the B comes over to the left. What can I multiply both sides by here? A. I get A times the sine of B is equal to H. Hey, if they're both equal to H, then they should both be equal to each other. In other words, B times the sine of A should be equal to A times the sine of B. I'm going to now make the formula look just a little bit different. I'm going to divide both sides by A times B. If I divide this side by A times B, what canceled? B. If I divide this side both by A times B, what cancels? And I end up with sine of A over A equals sine of B over B. Sometimes students ask the question, who made up math? I never want you guys to think that this just comes out of thin air. Somebody just made it up. We just proved it. Like, we made it right now, okay? Now, I can't take credit for that. I'm not the first person to do that. But the fact is we derived the formula. It's not magic. It's math. Well, you're allowed to divide by the same thing, aren't you? And maintain equality. So the reason why I chose to divide by AB is because it sounds nicer to say sine of A over A equals sine of B over B. I could have left it as B sine of A equals A sine of B, but that just doesn't ring as true to the mind, does it? No. So we have this law of sines. Given a triangle ABC with sides ABC, then we know this. The sine of angle A over side A equals sine of angle B over side B. Which equals, anybody got the last part? Sine of angle C over side C. You got all of them. It's good news. And it helps us solve triangles that are not right triangles. And I actually think for some of you, there are some of us who were not able to figure out how to solve the right triangles. I think that this is actually easier than solving some of the right triangles. So here's what we're going to do. This unit, you'll be solving triangles. And this will be on your final exam. This is one of the skills you want to develop. It is a must-know component of trigonometry. I can't have you pass trigonometry if you don't know how to solve triangles. It's what trigonometry really means. Remember when we did that? Now I'm going to make my triangle. I'm going to insert the angles. And I've got my sides. Now, test comes. Mr. Gantz is trying to give away some free points. What should you be writing down right now? Yes. Say thank you, Mr. Gantz, for some free points. We'll write down 42. We'll write down 80. We'll write down side A is 10. So I got to figure out 6. I've already got 3. One of these missing 3 is super easy to figure out. Which one? Angle C. Why? All angles add up to 180. So 180 minus 80 is 100. Minus 42 is 58 degrees. Anybody have a question with how I came up with 58? Okay. Now I need to come up with sides. And here's the key to the law of sines. You must have an angle and its opposite side. So, can somebody tell me the angle whose opposite side I know? A. So I say the sine of 42. So I'm using this right here. I have to have an angle and its opposite side. If you don't, it ain't going to work. We actually need a different formula, and we'll teach that later. So sine of 42 over 10 equals, now, would you like to find side B or C, Tito? It's up to you. B. Free country chooses B. So sine of, do I know angle B? Yeah, it's 80 divided by side B. What do you think I do? I cross multiply. I got B times the sine of 42 is equal to 10 times the sine of 80. How do I solve for B? Divide that sine of 42 off. I get B is equal to 10 sine of 80 over sine of 42. Do you think I should be working in radians or degrees in my calculator? Degrees. All the angles we were given were in degrees. So I go mode, and I grab degrees. 10 sine of 80. Make sure you close that parenthesis, divided by the sine of 42. Now you see why you got to have that calculator. And I get B is equal to 14.72. Can I use the Pythagorean theorem to find side C? Why? Because it's not a right triangle. A lot of people say, well, do a squared plus b squared C squared. It doesn't work. You don't have a 90-degree angle, folks. So we got to find angle C. I'm going to set up the same thing. Sine of 42 over what? 10 equals sine of what? Which is 58 over C. We cross multiply again. C sine of 42 equals 10 sine of 58. And divide. C is 10 sine of 58 over sine of 42. Anybody here got that graphing calculator? I'll show you a nice little way to save some time here. If you press second enter, it brings up the same entry. What's the only thing I have to change in this problem from there? What's the only thing that's different? Yeah, the angle, instead of 80, I want 58. So just go 58 and I'm done. 12.67. And now we assess the reasonableness of our solution. What's the biggest angle? Is that the biggest side? What's the smallest angle? Is A the smallest side? Yeah, and C is between them. So it looks like, for all practical purposes, we have a reasonable answer. Whether or not it's right, we'll have to check the answer key. We're going to do one more problem together in class. I want you to try to get started on letter B on your own because I forgot to run copies of your assignment. Let me quick do that. Try setting up B on your own, and we'll run through it together, okay? Sets up the same type of way, okay? Go ahead. Do that. Look at what you're doing. You're solving for a triangle here. We got A. What is A? We had to subtract from 180. What'd you get? 141. Sweet. That's the biggest one. Side A must end up being our biggest side. We got side A is equal to 10. Okay. So I should have sine of 141 over 10 is equal to, somebody, did you choose to find B or C first? What'd you do? Okay, we'll do B. So I got the sine of 12 degrees over side B. We cross multiply, and we get B sine of 141 is equal to 10 sine of 12. And we have to divide by sine of 141 degrees. What'd you get? Yeah? Peyton, you like that? Anybody else come up with something different where they see they made a small mistake? Can I show you how people come up with a mistake? They go like this. They go 10 sine of 12 divided by sine of 141. Why is that not going to be right? I didn't close my parenthesis. So you do that, and all of a sudden, you're like, well, I'm close. That's just by luck that you're close. You take that same entry, and you go in, and you insert that parenthesis. Now, that's the correct answer. See that? Okay, so we find C by the same thing. Sine of 141 over 10 is equal to the sine of angle 27 over side C. We cross multiply. 10 sine of 27 divided by sine of 141. 7.21. What do you think? Today, I'm going to give you half the assignment. We're going to do the first problem together. Okay, I'm pulling that worksheet up. Told you to set that first example up, see what we got. You're only going to focus on the odds today. Please do not go over to the evens. That's what we're going to work on setting up tomorrow with another skill as well. So I've got A is 85 degrees. I've got B is 32 degrees. I got side B is 20. So there's not a lot of space here, but we'll make do. A, B, and C. And side B is 20. Side C and side A. Okay, B is 32 degrees. Can you find C? What did you come up with for C? How about this? You tell me, how do I come up with C? Subtract from 180, so 180 minus that 85 minus that 32. As Jesse said, we got 63 degrees. Who said it? Oh, Tito. Tito says 63. We listened to Tito today. Okay, my pen doesn't write too well, but I'm going to do my best here. What do I got then? What do I want to set up? Sine of what over what? (32 over 20). You have to choose that because that's where you know the angle and the opposite side. Equals. Now you get to choose. Do you want to find A or C? All right, sine of angle A over what is the length of A? Or we don't know the length of A. That's what we're trying to find. Do we know angle A? 85 over side A. And we cross multiply. 20 times the sine of 85. And then we'll divide by the sine of 32. I get 37.6. Does it make sense that side A is bigger than side B? Why? Because angle A is bigger than angle B. I'm going to choose the same thing. Sine of angle 32 over 20 is equal to, now what am I trying to find? C. So sine of angle C is 63. That's what Tito told us. Divided by side C. (20 sine of 63). Well, parenthesis. Divided by the sine of 32. 33.6. Triangle is solved. That, my friends, is the law of sines. That is the easiest examples of the law of sines. So we must know that well. We do come up with some other ones that are a little bit more challenging. So we got to know that one well. We're going to get to the law of cosines and stuff later on and other stuff. So know this one. Your assignment, remember, is due the day of test, but you want to start now. Do problems 1, 3, 5, 7, and 9. And tomorrow, I'm going to show you how to do the even problems. We all good? What's that? What's different about these is you are only given one angle and two sides. So we're going to talk about that, and we got to refer to a flow chart. You guys have the notes that I gave to you? Somebody got them up here? So Sai's got notes right here and on the very back. These are the notes that you get on the next test. Okay? And this will tell you how to solve the triangles. We got to start to learn to read that and interpret that a little bit tomorrow. Okay? And trust me, we'll take it step by step, each situation. So Get to work, you can get it done.